Hello class. Today we're going to be focusing on synthetic division. Yay! So we're going to walk through the steps to do it, but first we're going to see why it exists and test another method to compare and contrast these different styles. So first, I want you to take a moment and try to do long division here, dividing this polynomial by this polynomial here. So we're going to do 2x to the fourth minus 15x squared minus 10x plus 5 divided by x minus 3. So take a moment, pause, and you will see me working through it in a moment. Alright, I'll begin working through this. Now, when you set this up, I typically like to have my x minus 3 set up to the side, long division symbol, for 2x to the fourth minus 15x squared minus 10x plus 5 written. Now, there is a problem with the setup. I should always make space for degrees that aren't clearly shown. So I'm going to draw that in green after I move this all over. Sorry, I'm not great with this tool yet. See, I just clipped it a little bit. So I am missing a third degree term, so I'm going to put plus 0. And I think that's it. This is my x to the third. That should work. Alright, so let's keep moving on forward. And as a refresher, when you are doing this, you always want to figure out how your leading term, and let me highlight this, your leading term here fits with your leading term here. So we have x, and we relate that to x, 2x to the fourth. So the factor here is going to be 2x to the third, and that's going to create 2x to the fourth for, in relation to this, and we multiply that throughout, and we're going to get 6x to the third. That's going to be minus 6x to the third. We take the difference of those two, so we're distributing a negative through those, and you'll see that these will cancel out, and you're left with, in your next drop down, and I'm going to make this purple to continue it, and this is going to be plus now 6x to the third, and the 15x squared gets dropped, so minus 15x squared, and now we look for this factor. I'm going to do that in yellow at the top and say that we have here plus 6x squared, and that's going to give us this leading term of x cubed minus, in this case, 18x squared. And remember to take the difference. I always put the negative there and draw the parentheses to note that I am clearly doing this. So when we get the difference for this, those will cancel out. And you're left with a positive 18x squared. Taking the difference of negative 15x squared, you're going to be left with 3x squared. And bring this down, you're going to be left with minus 10x. And we keep going back to this leading term. And here now we have plus 3x. I'm not happy with my... I'm going to move this over. Yeah, I'm not happy. Sorry, I'm trying to do this. It's very hard on this program. There we go. I like that alignment a little bit more. Okay, so going back to this. So I brought that down, and now I'm looking to see that 3x is my next factor, so this can become 3x squared, and this can become minus 9x. Because remember, we're distributing the 3x. Let me point to that 3x to here. And we have a negative that's distributed. Take the difference, cross those out. Remember, we always want to have that system where it's being crossed out. If it's not, well, then we're running into a bad time. And you should get a positive 9x to negative 10x. You get negative x. And now bring this down. This was plus 5. So plus 5. And now, simply, again, what's the next factor? Well, you just have negative 1. So here, negative 1. Yeah, negative 1 here. X, negative 1x, my apologies. And you're going to have plus 4. No, well, not 4, 3. And we have a negative being distributed this whole thing. So this becomes positive, those cancel out. And you're left with a negative 3 and 5. And you have a remainder, or this ending of 2. So I've already given it away slightly, but we actually have names for different parts of this long division process. And I'm going to highlight them here. The top, this is your quotient. This is what you get in the end when you're dividing. This is the polynomial remaining. This is your dividend, what you're dividing into, dividend, and this below is your remainder. Now I write all this out because we're going to look at this from a different perspective in just a moment. So for part two, I want you to consider this equation. Here we have it as the same one as we had before, of 2x to the fourth minus 15x squared minus 10x plus 5. We consider this actually to be p of x. That's equal to this. And I want you to solve for p of 3. So take a moment and try that out. So if you did your setup correctly, you should have noticed a very wild thing just happened. So I'm going to unlock my screen and zoom in on this. Sorry for the too much zoom. Let's set this up, and I'm going to set it up in purple that we have synthetic substitution. 3 is what we're plugging in. Leading coefficients 2, 0. Don't forget the third degree. Negative 15, negative 10, and 5. And here, draw a little line there. I'll start noting what happens. We drop the 2, multiply the 2 times the 3, you get 6. Drop the 6 further, you add those together, 0 and 6. 3 times 6 is 18. 18 plus negative 15, you get 3. 3 times 3 is 9. 9 plus negative 10, 1. And now 3 times 1 is 3. And I think we should be alright. Oh, wait, hang on. Forgot that this should be negative 1. My apologies. So this should be negative 3. So this should become 2. And this here is very interesting because note in red, I'll draw this here, is also your remainder. This, notice like the yield that says that, so p of 3 is equal to 2, and when you divide by the factor x minus 3 into the same equation and you get the same remainder out, that's fantastic. So we actually have this theorem called the remainder theorem, and I'm going to write this in green on the side, the remainder, can't spell tonight, theorem. That's the way I write theorems. It's fine. That when p of x is divided by a x minus a can be any integer here, the remainder will be simply p of a. And that's pretty handy. So by using synthetic substitution, we get a remainder. And this is how we get to the topic of synthetic division. All right, let's move on to another theorem. So for this example, we are told to divide the function p of x, which is equals to x cubed plus 5x squared plus 5x minus 2 by x plus 2 here. So take a moment and attempt that. Alright, now I'm going to walk through this with you. Now, I'm actually going to use synthetic division here. It is a great tool, especially when you don't have a calculator, or if you just want to, in the end, save some time. Because if you actually compared our last two methods, synthetic division is much faster, I'll say, in comparison. So, if I'm going to do this, note that what we're plugging in is the opposite of this here. Let me point to it. The 2. So I like to think of it as it's x plus 2, you're solving for 0, and x is what you're plugging in once you solve for it. That's the way I like to look at it. So negative 2 is we haven't plugged in, and we have to look at our coefficients now. So that's 1, 5, 5, if you can read my terrible handwriting, and negative 2. Now I'm going to draw a line. Also, I would also say it actually conserves a lot more space. So we bring down the 1. That's 1. 1 times negative 2, negative 2. Sum those together, 3. 3 times negative 2, you get negative 6. That's going to be negative 1. Negative 2 times negative 1 is going to be 2. Oh, look at this. We actually get a remainder of 0. Well, what does that mean? What does that entail? Simply put, this means that x plus 2, and x plus 2 here, if it gets a remainder of 0, means you actually have this here, this function. X plus 2 is a factor of this function, giving you 2 factors, one of this, and actually if we write out all these terms, one of this, to yield a product of this. And let me write those out. So we have x plus 2 is equal to, in this case, we have x squared plus 3x minus 1. And together, this will equal our original p of x function, x cubed plus 5x squared plus 5x minus 2. So, all in all, what does this mean? Well, this means that we just reasoned out the factor theorem. Again, my handwriting is not great, but we're getting through it. That for polynomial p of x, x minus a is a factor if and only if, that's huge, if and only if when p of a, so we're doing the synthetic substitution, is equal to 0. So your remainder is 0. So went through synthetic division. Hope you enjoyed. Remember, it's not magic. It's a tool that we use, just like any other tool in mathematics. There are reasons behind it. And I hope you enjoyed today's lesson on synthetic division.